Hello students, welcome to the third part of the numerical series on the topic reflection of the chapter Light class 10. Okay, so in the previous two videos you have done already 20 questions. Here is question number 21. Let us read the question, what it is saying. An object of 5 centimeter in size is placed at a distance of 20 cm from a concave mirror of focal length 15 cm. At what distance from the mirror should a screen be placed to get a sharp image? Also calculate the size of the image. Now children, just see whatever is given first. So object size, it is given 5 cm. So HO 5 cm. The object is placed at a distance of 20 centimeter, so U is negative always, so minus 20 centimeter. Focal length for the concave mirror is what? It is always negative, so 15 centimeter minus 15 we have written. We got two values to get the distance of the image. Here in the question, at what distance from the mirror should a screen be placed to get a sharp image? Screen should be placed where? Wherever we are going to get the image, isn't it? So it is the image distance we are calculating, so that is V. Okay, so use the mirror formula. After calculating, you are going to get minus 60 centimeter. Do it in a proper manner after substituting the value. Complete work you have to do. Here I have shown only the calculation part due to shortage of place. Okay, so V is, here we got negative sign indicating what? It is a virtual image. But let us see. Now we have to find the size of the image. Size of the image, for that we the formula is saying what? M equal to HI by HO, but M value we do not have. HO value we have, so HI, for getting the value of HI we also need M values. So another formula of M we have to use, that is minus B by U. Now just put all the values. B is minus 60. Here already minus is there. Minus 60 will become plus 60 here. After that, U value is how much? Value of U is minus 20. So substitute this and you will get M equal to minus 3. Okay. HI by HO equals to M. This equals to M. So M value is minus 3, just we have substituted here. HO is how much? It is 5. So just multiply these two and you will get minus 15. Now let us try to answer. In the green boxes it has been shown that how to answer it. Okay. First is at what distance. So the screen should be placed. The screen should be placed at a distance of 60 centimeter in front of the mirror. Okay. So here it is negative sign, so this image has to be real one, right? So it has to be in front of the mirror, because we know in case of concave it is always real when it is in front of the mirror. So that is the reason it is showing V's value is showing negative here. Earlier I told it is a virtual. No, it is negative, means it is a what? It is the real image. So first part we have written. Now calculate the size of the image. The size of the image formed is 15 centimeter. Clear? So let us move to the next question, that is question number 22. Question number 22 says an object of 4 centimeter high is placed at a distance of 6 centimeter and it is a concave mirror of focal length 12 centimeter. You have to just see that same question with different digit values, and here only you have to mention the answer in terms of position, nature and size of the image. Now HO is 4 centimeter. U is how much? It is 6 centimeter given in the question. So minus 6. As you know, U is always negative. Concave mirror, focal length will be negative. Now these two value you substitute in the mirror formula and you will get the V value as 12. Now here the value of V is what? It is positive sign. So that means the image must be virtual one. There is a case in concave mirror where we get the virtual image. You know, there is the only one case. Now that is the nature you got from this positive value of V. So here again we have to find out the size of the image. That is what? That is HI, right? HI we have to calculate. Now again use this formula to get the value of magnification. So minus 12 by minus 6 will give you simply 2. Here minus is cancelled, isn't it? So M value we have to substitute in the formula. HI by HO equals to, that's equal to how much? That is M. So in place of M directly we have written 2 here. HO value is how much? It is 4. So just multiply both of them. After multiplying you will get 8 centimeter. Now let us now answer this particular question what has been asked. In the green boxes it has been mentioned position. First of all, the position of the image is 12 centimeter away but behind the mirror. You know it is behind the mirror as it is a virtual image case. Now the nature of the image is virtual and erect and the size of the image is 8 centimeter. I hope this is clear to you all. Let us move to the next question, that is question number 23. A concave mirror used in a bus has radius of curvature 3.5 meter. If the driver of the bus locates a car at 10 meter behind the bus, find the position, nature and size of the image of the car. Now, radius of curvature is given. Radius of curvature is given, that is 3.5 meter. Then 10 meter behind the car. Here the bus mirror is the whatever mirror we have already, that is the convex mirror it is written, and car is the object here. Okay, car is the object here. So let us substitute, or whatever given data that we will write u equal to minus 10. Here it has been given r is given 3.5 meter. So we can easily calculate the value of f, that is 1.75. Now substitute the value of u and f in mirror formula, you will get value of v. Value of v will become 1.489, or tentatively you can also write 1.5 meter. Okay. So now again we have to find out the position. Position it is already we got v equal to in a positive positive value. So the nature will be what? Virtual. As it is, you already know it is a convex mirror, means always the image will be virtual and erect, right? Now the size of the image, what will be the size of the image, that we need to calculate. But here just remember, HO is not given, HI is not given, HI is asked rather, and M value also we do not know. So what we have to do is M equals to this formula we have to put. Directly you can write here 1 point, because I have got this particular 1.48 value. I have tentatively taken minus 1.49 here, then minus 10, you will get this much value, that is 0.149, and M tentatively what will be the value? This is 0.15. Now you know M values is M formula is HI by HO. So I have just substitute the value over here, because we don't have any of the data out of these two, HI and HO. So I just simply I can write what? I just write that HI equals to 0.15 HO. Okay, this can be written how? HI is whatever is the size of the image is 0.15 times than that of the original object size, right? So let us see how to mention this, how to answer this. First of all, it is asking for the position. The position here, just see, the position of the image is 1.489 meter, or directly you can, that round of value you can use 1.5 meter in front of the mirror. And then second is, it is asking for the nature. The nature of the image is formed is virtual and erect. Then the size of the image, that is the size of the image of the car is 0.15 times the actual size of the car. Okay, this is the answer that you have to mention. Clear? I hope this is quite clear to you all. Let us move to the next question, that is question number 24. What it is asking, the radius of curvature of a convex mirror used on a moving automobile is 2 meter. So R value has been given. A truck is coming behind it at a distance of 3.5 meter. That means here what is the automobile, and the behind it who is coming? A truck is coming. Okay, so the object is truck over here. From the mirror the distance is 3.5 meter. We have to calculate position, size relative to the size of the truck. It is just mentioning the way the question is in a different style it is been given. The process will be the same. Okay, what will be the nature of the image? Same questions, but it in a twisted manner it has been asking. and it is in the question you will get a different type of answer. So I am making you practice that one only. Okay, so u is how much? U is, here it has been given 3.5 meter, right? So just directly I had written it is 35 by 10. 3.5 is 35 by 10, right? And 35 by 10 will be, if you will divide by 5 you will get 7 by 2. Okay, now r is how much? It is 2 meter. 2 meter, so f value we will get 2 by 2, that is 1 meter. Substitute these two values here to get the value of v. You will get how much? 7 by 9, or you can just divide it to get a decimal number, because this answer we cannot write, just decimal number you have to use for the final answer, because here it has been asking the position of the image, right? So you have to just find out this decimal number, 0.78 meter. Now again, for getting the size of the image, we have to put the same formula, m equal to minus b by u. So here again we by substituting the value, m value will become 2 by 9. Okay, again we know hi by ho is 2 by 9. So hi equal to 2 by 9 times of ho. Same thing, only in the previous question we got 0.15. Here 2 by 9 we have to mention. Whatever value we got, we have to mention that way. Either you use directly for this particular question, for the size comparison, you can either write 2 by 9 in a fractional number, or you can use a decimal. Just divide it, and whatever decimal number you are getting, that also you can use. Okay, now this is the way how to represent. You just go through it, you will able to answer. Okay, you will able to write by your own as well. So let us move on to the next question, that is question number 25. A concave mirror produces 3 times enlarged, but it is virtual image of an object placed at 10 centimeter in front of it. Calculate the radius of curvature of the mirror. Now you just see, object is placed, object is placed at 10 centimeter in front of it. Okay, so u value is minus 3. It's a 3 times. Now again, if you remember in the previous videos I told you, if the object size and the image size is been compared with this is the value for what? It is the value for magnification. So m becomes 3. Whether it is positive or negative, that we can write from the type of image. It is a virtual, so it will be positive. If at all here in the question it will be given as a real image, then you have to write just m equal to minus 3. Now from this you substitute the value in this formula. We know that m equal to minus b by u, so minus b by u, and the value of m we have input here, that is 3. Now just see, v equals to minus 3u, we got this one. Substitute the value of 2 here, this is the multiplication, and after multiplying you will get 30 centimeter. Got it? Now we have to calculate the radius of curvature of the mirror. Just the twisted thing it has been given, so we have to find out the f. Okay, now use the mirror formula, because we have u and v value. So just after substituting we get the value of f as minus 15. So for getting the radius of curvature, r equal to 2f is the formula, r equal to minus 30 centimeter. Now ultimately just put a 3 dot like this and just write it down. The radius of curvature of the mirror is minus 30 centimeter. Here you have to write at the bottom again the answer. I hope it is clear to you all children. Let us move to the next question, that is question number 26. This is also a quite easy question. A 2 centimeter high object is placed at a distance of 20 centimeter from a concave mirror. Okay, so HO is been given 2 centimeter, object distance is minus 20 centimeter. The real image is formed 40 centimeter from the mirror. Now V is also given. Okay, it is a real image, so it has to be negative. So minus 40 centimeter we had given. Just check from you have to read the question very carefully, because all the sign notation, what sign you have to put, that is already given in the question, and from that you can calculate it very easily. Okay, now it is asking for calculate the focal length of the mirror. Okay, so use the mirror formula, substitute the values. Okay, it is just the height is height of the object is just mentioned in the question, just an extra information. There is nothing to do with this question. Okay, So just make you confused. It has been given, but whatever is given, you need to write it down. It is required. Okay, so after calculating, you will get f equal to minus 13.33. Just see children, it is a concave mirror and focal length over there is has to be minus in negative. So it is we got the answer in negative only, right? At the end again you have to write like this. The focal length of the mirror is how much? Mirror is minus 13.33 centimeter. I hope it is clear to you all. Let us move on to the next question, that is question number 27. Right? Question number 27 says, where should an object be placed in front of a concave mirror, okay, in front of a concave mirror of focal length 20 centimeter, so as to obtain a real image 2 times magnified. Okay, so magnification is here already given as 2, but here it is a real image, so m becomes minus 2. Focal length, it is a concave mirror, f equal to minus 20 centimeter, right? So we have to find out where should be the object placed. So object distance we have to find out, u we have to find out. We know that u value is always in negative, so minus x we had taken. Now very easily we can calculate by the small formula of m, that is this one, because we have m value and you have to substitute. So v we need, right? So we have to calculate from this formula m equal to minus 2. Then v, in place of v we have to write v only. In place of u we have to take x. Already minus is there in the formula. X value is also minus. So minus minus it becomes plus. I hope it is clear to you all. V equal to, now cross multiply these two, you will get minus 2x centimeter. All these values, now you have to substitute. We got u ka value as we had taken, I mean minus x, v value we got minus 2x. So what we will do in this particular formula, we have to substitute everything, and ultimately f value we will get 30 centimeter. U is, what is the value of u? That is minus x. Now x value is as we got 30, we have to just substitute minus 30 over here. I hope it is clear to everyone. Just think about it, the question, you can easily do it. Let us move on to the next question, that is question number 28. 28 says, an object of 5 centimeter tall was placed in front of a spherical mirror, okay, and it is 20 centimeter distance. Object distance has been given. If it is a virtual image, now it is a virtual image. We do not know, virtual image is formed both in concave and convex. Of 10 centimeter tall was formed behind the mirror. So it is given what? It is image size, it is been given. HI is been given here. Find the focal length. F we have to calculate. Position of the image, that means V we have to calculate. And what type of mirror? See, a very new type of question it has been given. So what type of mirror we have to see. From the F value we will get it. Okay. So just let us see further. After proceeding you will able to understand. So H value 5 it has been given. HI already I told you, that is 10 centimeter. This is HI given. Then it is a object distance. The object distance is minus 20. Now m is how much? M formula is what? HI by HO, because we have both HI HO here. So you will get the magnification value, that is 2. Here you will get 2, right? So we know another formula to get, we have u, we have to find out v. So just substitute the value of u over here, multiply, cross multiply with this, and you will get 40 centimeter. 40 is this v value is positive over here, isn't it? Positive means it is a virtual image. It is already given in the question. The question arises whether it is a concave or convex. That will be clear from the focal length value. So let us use the mirror formula, that is this one. Now u value, v value you know. Substitute those value. After substituting you will get f as minus. F minus means what type of mirror? It is a concave mirror. It is a concave mirror. Okay, it is a concave mirror. I hope it is clear. Now just answer all the question it has been asked. It is asking for the focal length, then position of the image, v, and type of mirror. Okay, so here first of all you should write the focal length. I have written at the bottom, so better you will answer this in the beginning. So the focal length is 40 centimeter you have to write. Then the position of the image is 40 centimeter behind the mirror. Okay, because it is virtual, so it is behind the mirror. As it is, whether it is a concave or convex, you know virtual is behind the mirror, right? So you can write directly over here. Now later, from the f value which is negative, we concluded that the type of mirror is concave. I hope it is clear, children. So let us move to the next question. Question number 29. A 2 centimeter high object is placed where at a distance of 32 centimeter in front of a concave mirror. The image is real inverted. Okay, one hint has been given, and 3 centimeter in size. The focal length, find the focal length, you have to find f, and then here you have to find f, then you have to find the position of the image, that is v, you have to find it out. So what we have in data given is 2 centimeter high object, that is ho is been given. The size is 3, hi equal to 3. It is because it is real, so it is below the where it is the principal axis. Suppose whatever is the mirror, so below it, that means what, it will be negative, isn't it, according to the sign convention. So here you have to write minus 3 centimeter for hi. U is always negative, so minus 32. Now m value is how much, hi by ho minus 3 by 2. We substituted the values and we got v. After putting the value of u as well, we will get that v equal to minus 48 centimeter. Okay, minus sign again, it is indicating what, minus sign of v, it has to be real and inverted. It is given in the question also. So if at all your answer is not coming in minus, then you have to recheck it, because it is real means v has to be negative. Okay, I hope it is clear, all the tricks that I am giving, that you have to clear it out now only. So this is the mirror formula. In the mirror formula, we already got the value of u and v. Now substitute these values and you will get f as minus 19.2 centimeter. Means it is a concave mirror, isn't it? And in the question also we have concave mirror. So that means you have proceeded with the correct process. Now focal length we got, so you have to write the image is formed 48 centimeter. It is the position it is asked. So again I have written this part at the top. You write this one in the beginning. The focal length of the concave mirror is 19.2 centimeter. This one, the image is found 48 centimeter away from the pole in front of the mirror. This too is asked, so you have to write accordingly. That is important, children. Just remember at the end, whatever question is been asked, that you have to mention at the bottom of your answer. I hope it is clear, everybody. Yes, so let us move to the next question, question number 30. Okay, question number 30 says an object is placed at a distance of 12 centimeter in front of a concave mirror. The radius of curvature is 30 centimeter. 4 characteristics you have to write, okay, for the image. Let us see how to write and why we need to write all of them. So first of all, the data is minus 12 for u. R is been given minus 30, okay, because it has to be calculated from pole. Okay, so it is minus 30. F equal to R by what, 2, that is minus 15 centimeter. Now substitute the value in mirror formula, this one, so you will get v as 60. Now v is positive, you know what it is, it has to be virtual. 4 character we have to write, 4 characteristics. So first one is virtual, we have written. Along with virtual, always direct, you know. The size is enlarged, okay, because we already know from the what it has been, it is a concave mirror, and the image that is forming, it has to be what, virtual means it is always enlarged, because concave mirror has only one case where the nature, we know that it is virtual, erect and enlarged one. So enlarge in size, and because it is a virtual, it will form behind the mirror, and thus we got 4 characteristics. Got it? So now let us move to the next question, that is question 31. An object of height 1.2 meter is placed before a concave mirror of focal length 20 centimeter, so that a real image is formed at a distance of 60 centimeter from it. Okay, 60 centimeter from it. Find the position of the object. What will be the height of the image? Okay, we have to find out the position of the object, that is u, and we have to find out the height of the image, that is hi. Okay, these two we have to calculate. Whatever is given, now first of all children, whenever there is a numerical, you have to check the units. It is in meter, these are in centimeter. So first of all, HO, object height HO is been given. HO you have to write always, don't forget. So 1.2 meter, I am converting it into 120 centimeter. Okay, because focal length is also given 20 centimeter, so here it is minus 20. V is what? It is it is a real image, so I have to use the negative sign here. So minus 60 centimeter I had given. This is the mirror formula. In the mirror formula we have to substitute f and v's values, and we will get u as minus 30. Okay, u has to be minus always. So your calculation is quite clear from this. Okay, now here m value, m formula is minus b by u, that we have to take, because for the height of image height, we need height of the object as well and magnification value. So magnification value we need to find it out. Substitute the values of v and u and you will get minus 2. Substitute it with hi by ho. HO's value is 120 centimeter. Just multiply with this 2 and you will get 240 minus 240 centimeter. Again, because the height of the object is in meter, so I have converted it in meter as well. Okay, so children, you have to remember all this while answering. Now find the position of the object. This is the object position, that is 30 centimeter away in front of the mirror. Away from where? From the pole in front of the mirror, or you can say 30 centimeter away from the mirror. Then the height of the image is this much, which just now we had calculated. I hope this is clear, children. Now question number 32, which is the last question and one of the very interesting question. In this question, as you can see from the solution, there is a ray diagram. So just go through the question. I hope it will be clear to you after completing this particular solution. The image of an object formed by a mirror is real, inverted, and magnification of minus 1. Very clear indication if m equal to here given minus 1. Okay. If the image is at a distance of 30 centimeter from the mirror where the object is placed. Okay. So that means it is asking for u. Okay. Find the position of the image. It is asking for b as well, right? Position of the image is now moved 20. It is a case 2. Okay, it is case 2. First of all, till this part, if the image, come to the second line, if the image is at a distance of 30 centimeter from the mirror, where is the object placed? It is a first part of the question. Now it is saying that find the position of the image. Again, image position it is asking. If the object is now moved 20 centimeter towards the mirror, that means suppose object is here in the concave mirror, then it is been placed 20 centimeter towards this. Okay, this one is 20 centimeter. 20 centimeter it has been shifted. So originally the distance was how much? It is 30 centimeter. So 20 it has been shifted towards the mirror. So that means the object is placed 10 centimeter away from the mirror. I hope it is clear, children. Now what is the nature of the image it has been that you obtained? I mean after shifting the object towards mirror 20 centimeter, what is the nature of the image and the ray diagram you have to draw. Okay. So got it? Now magnification has been given minus 1. Let us substitute with the value with the formula of minus b by u. Now from that you will get u equal to b equal to minus 30 centimeter. B by u minus b by u equals to minus 1. So now cross multiply this, minus b equal to minus u, which is given as 30 centimeter. Isn't it? So b equals to u equal to minus 30 it will be. Right? Because we have to, if omit this particular sign, we have to put it here. So by default also you know u is always negative. I hope this part is clear. So the first part, where is the object is been placed, we got this. Object is placed 30 centimeter away from the mirror, okay, in front of it. Obviously it is the object distance. Now image position v we have to calculate if the case is different. Now what is the we know what is the value of f. F is been what, r equal to 2, because here one more thing you have to notice, children. It is in the second case it is minus object distance is minus 10 centimeter, but here in the previous case what we had seen, u equal to v. Wherever object is been placed, v is also over there. So this is the only case in place of concave mirror. It is the place at curvature, center of curvature at C, right? That means what? It is at the distance has been given 30. That means this is what distance? This is r as well. So the half of it is focal length. Thus you will get minus 15 centimeter. I hope this part is clear. I am repeating this, children. U and V are equal. That means there is only one case, that is at the center of curvature, isn't it? And it is of same size, because magnification is 1, it is of same size. This again, magnification is of same size is one of the hint. Then u and v distance is same, so that it has to be at the center of curvature. Center of curvature means that distance from the pole is what? It is r, radius of curvature. And we need f value. F value means f equal to r by 2. R, what is the r value? That is the object distance only in this case. That is minus 30. So minus 30 by 2 is 15. We need to calculate the focal length. Now we know that the object is been shifted to this place, right? So at this place, this object distance becomes how much? It is 10. 10 means minus 10. So we got 2 value. Now substitute in this particular formula. After substituting, you will get v equal to 30 centimeter. V is positive here. So it's a what? Virtual image. It is a virtual image in the second case. Okay, in the second case, not the previous one. You must be getting confused here. In the first case, it is a real one. Now the object is been shifted towards the mirror. After shifting, the position of the object becomes different. It is in between the pole and focus. Okay, it is 10 and focal length is 15. And object distance is 10. So that means the object must be in between focus and pole. I hope it is clear. Now you have to answer. First of all, the object is placed 30 centimeter away in front of the mirror. It is the first case. This question's answer. And secondly, in the second conditions, it is saying that what is the position of the image. So image is formed 30 centimeter. Here we got 30 centimeter behind the mirror, and image is virtual and erect. Obviously it is behind the mirror means it is virtual and erect. Now this is the condition of the ray diagram. Already from the ray diagram I explained you. So you try to draw this after getting all this. This is focal length, this is object distance. After doing all this you will get it. Okay, first case diagram also you can draw easily by showing the case of object at center of curvature. I hope all these things are clear to you. With this, we come to an end of the series of the numericals for the topic reflection. With few more questions, I'll see you in the next video. Till then, bye-bye.